Hello. Let's solve some systems using elimination. So on number 1, we're actually already set up for elimination because we have one of the variables, y, has coefficients that are opposites. We got a positive one and a negative one. That's what you need to have in order for elimination to work out. So all we would need to do in this case is to add the two equations together, adding like terms. So x plus x is 2x. Positive y minus y is 0. So we don't have to write anything. And then 2 plus 4 is 6. And the reason why elimination is cool is because we just eliminated the variable y. And now we have an equation that only has x in it so that we can now solve for x. So 2x is 2 times x. So in order to get x by itself, we have to undo the times 2, which you do by dividing by 2. It's like a tongue twister and a poem at the same time. So 2 divided by 2 is 1. So we get x equals 6 divided by 2 is 3. But we're only halfway done because remember the solution to a system is an ordered pair that represents the point where the two lines would intersect, because the graphs of these two equations are lines. And all we know right now is that the x value is 3 for that point. What we need to do is we need to plug back into one of these equations, and it doesn't matter which one, to figure out what y is. So I will do x plus y equals 2, and then I'm going to plug the 3 that we got for x in for x. So 3 plus y equals 2. And then to get y by itself, I need to do the opposite of adding 3, which is subtracting 3 from both sides of the equal sign. 3 minus 3 is 0, so I just have y left on the left. 2 minus 3 is negative 1. So I know that y equals negative 1, and the answer, the solution for number 1 is the point 3, negative 1. So now on number 2, we're not set up right away for elimination. If we were to just add straight down, we would get x plus x is 2x, 2y minus y is y, so plus y, and then 6 plus 3 is 9. Now there's not anything wrong about that, but it didn't eliminate a variable, so it doesn't get us any closer to our answer. So what we need is we need the coefficients of one of these variables to be opposites. And I could get that with x's if I was to multiply one of these equations by negative 1. And I could get it with y's if I was to multiply the bottom equation by 2. And so you might say, well, how do you get that? If I'm looking at the y's and I want to cancel out the y's, this one is a positive 2, so I would need this one to be a negative 2. So if I multiply this whole bottom equation, or you might think of it as multiplying both sides of the equal sign by 2, I would get another equation that I could put underneath x plus 2y equals 3. And I would have elimination because I would have a negative 2y. So let's do that. 2 times x is 2x. 2 times negative y is negative 2y. And then 6 times 2 is 12. Now when I add straight down, I get x plus 2x is 3x. 2y minus 2y is 0, so that's nothing. And that equals 3 plus 12 is 15. And now I can just divide both sides by 3 to get x equals 5. But that's only half of my solution, remember? My x value is 5. I need to find my y value in order to be done here. So all I need to do is plug the 5 in for x in one of these equations. So I think I'll pick the original bottom equation. X minus y equals 6. I'm going to substitute a 5 in for x. 5 minus y equals 6. Now what this is I got a positive 5 minus y, which is the same thing as negative y plus 5. So what I'm really doing to the y is adding 5, and there's also a negative 1 multiplied by it. So I'm going to get rid of the adding 5 first. I'm going to do minus 5 from both sides. 5 minus 5 is 0. And then 0 minus y is just negative y. And then 6 minus 5 is 1. And then I have negative y equals 1. So if I divide both sides by negative 1, I get positive y equals 1 divided by negative 1 is negative 1. So my solution there is 5 and negative 1.